Okay, in the next section, we're going to be talking about pre and post simulation adjustments, or you can also think of this as art direction. Um, it's going to be kind of broken up into a number of different parts. So um, these these are just kind of examples of things that you can do to kind of address art direction and comments you may get. The first one is how to prune agents procedurally. Um, you get some comments and you need to remove agents that go into a particular area, kind of how to achieve that and how to achieve it so that you can rerun your sim and it just will accommodate for that automatically. Um, the second part is kind of the next two lines. It's using one set crowd sim to influence a separate crowd sim. Um, and then resimming specific crowd agents. So these guys are kind of bundled together. And the idea here is that you can do one crowd sim, which can be like, your hero motion. And then, so say you had a bunch of agents and you wanted them to move in a particular way. And then um, you kind of had secondary agents that you wanted to be influenced by those initial agents and move out of the way of those guys, and how to do that as two separate simulations. So that's the first example. And then the second example that is kind of similar is this idea of resimming specific crowd agents, and the workflow around that. And then following that, we're going to have this follow curve example. So we're going to start off by using the existing follow curve tool, and then we're going to take a look at that briefly, and then we're going to create our own custom follow curve tool and discuss how that works. And the idea behind this is to show um, what kind of control you can get in terms of agent movement and how you can get very, very specific control. It's less about this tool specifically, but to give you an idea of what you can do in terms of flexibility, and hopefully that'll inspire you and allow you to try some different things. Okay, I will see you in the next video. In this file, we're going to talk about pruning out agents post-sim and ways to kind of approach this. And we're going to do this with the kind of idea of setting it up procedurally. So pretty basic setup here. We got run. We got some terrain. We got our mocap biped setup. We got a crowd source. We got the crowd sim. We have a top net. The top net is looking at this null node inside of crowd source, and that null node is attached to this DOP.io node, which is basically fetching the crowd sim from the DOP network up here so that we can cache it to disk. We have a file operator that's going to read in that cache, that sim, once it's written out to disk. And it's using a channel reference from the top node that we created over here to make sure we're reading in the right thing. Okay, we're going to provide you with this file, so you should be good shape and should be able to follow along. So the first thing I'm going to do is come in here and actually simulate the crowd so we have something to work with. So right-click, dirty and cook this node. And this is fairly quick. Should see you in a minute. Okay, that finished fairly quickly. We can come back over to here, and you'll notice that there's this node here called post-sim prune. So let's dive in here and take a look at it. Okay, so here's a sim. I'm going to say, we like it, but there's some agents here in the middle that we want to get rid of. We're just not happy with the distribution or whatever. So I'm going to start by grouping those guys and group points. Just do a box selection, grab some guys, hit enter, and there are group points. Then I can drop down a blast after the fact and just delete. I'll rename this group something intelligent. So let's call it Prune. I'm going to come to the blast. Just type in Prune. And there we go. We now have a gap in the middle. And we play forward and we're in good shape. Okay, so this is great. Say you're an artist and you submit this to dailies and your supervisor takes a look at it and it's like, hey, this is great, but can we, alter the number of agents in our sim? Can we make fewer of them? And you go, yeah, sure. And you come back, you go to your crowdsource, and on your crowdsource, you change the number from 750 to 500. And for those of you who didn't see that, I'm just 750, 500. Okay, great. So that's the new number. We're going to have to recache the sim, right? Because the one we have on disk has a different number. So let's go do that. We could come over to our top network. We have our old sim cached. I'm going to right click and go delete this node's result from disk. Okay. And then I'm going to right click and go dirty and cook this node, which is basically going to resimulate. And I'll see you in a minute once this is done. Okay, we're done. Let's go back and take a look at our post-sim prune and see what we got. Okay, so everything looks fine, but this is a little deceiving. We've cached the simet to disk, but the file operator we're looking at still has the geometry from before the sim. So we can, if we hit reload on this file operator, you'll see it updates with the new Sims geometry. Another way to do this is just going to scroll off the current frame and then scroll back. And as soon as you change frames, you're forcing an update of this operator, and you'll have the new information. So let's take a look at what we got in our prune. So our prune object, we have our object merge, and then we have our group. And the first thing you notice about our group is that the distribution of agents that we've grouped has changed. This is because they're grouping them based off point number. And as the simulation is, changed, there are fewer number of agents. This selection is no longer valid. We could come over here and just, reselect our agents, which is simple enough to do. Hit enter, and then that's reselected, and it works as before. But it would be nice if we could do something a little bit more procedural. So let's talk about how to do that. Yeah, so I'm going to blow this away. And the next thing I'm going to do is drop down a box. And I'm going to change its size to 20 by 20 by 20. Okay. So, and this is basically going to be what I decide to prune, or the area I decide to prune. And then I'm going to use a group. And I'm going to group points, and I'll keep it in the bounding region. I'm not going to use a bounding box. I will use a bounding object. And there we go. So we can blow these guys away. Great. And afterwards, we can drop down a blast. And we'll rename the group to Prune. And we'll blow away. Okay, so now we have, our hole in our deleted area, and we're in good shape, right? Well, not really. So if we play this forward, you'll notice that as the agents enter the box, they're being deleted, and as they exit the box, they're showing back up. This is probably not what you want. You'll probably want the selection, the deleted selection, to be persistent and move with the rest of the sim. So the agents that are deleted on the first frame, you still want them to remain deleted. So how can we do this? A number of ways to achieve this. We're just going to kind of explore one of them. Yeah. So let's take a look at doing that. So yeah, real easy way to do this is we have this group that we've made. We can drop down a time shift. And a time shift, basically, there's this parameter called frame, and this says on the input, this is the, whatever the input is, evaluate it on this frame. So I'm just going to, make this, freeze this on frame 1. So, I shift the timeline forward and it doesn't move at all. And now what I can do is something very simple, just use a group transfer. And I'm going to transfer the point group, call it Prune. Then I'm going to drop down a blast. And I will delete the Prune group. I'll change this to points. I like to be explicit in terms of which point group I'm deleting instead of guess from group, unless I have a specific reason. I just find it keeps things cleaner. Okay, so now if I play forward, oh, well, something's wrong. Oh, group transfer. I don't want group transfer. I want group copy. My mistake. So group transfer is going to transfer the group based off proximity, which is not what I want. I want this to transfer based off my point number, which is very, very specific. Okay. Now let's see what we got. See if this works. So yeah, this is working. So you have this kind of mechanism where the selection that you chose on the first frame and then we established on the first frame is now being copied over to this animated section, and then we can use a blast to get rid of it. And this will work. If we change the number of agents, you'll see that this works. So let's go back to our crowd sim. We can change the sourcing back to 750. And let's go back to our top net, delete this node's results from disk, right click and dirty and cook this node's results. And I will see you when this simulation finishes. All right. The simulation is done. So let's see if things have updated as we'd expect. And it looks like it's not working. Let me see if I can figure out why. All right, so it's grouping those guys. That seems to be working properly. Time shift, yeah. Group copy, and then blast. Let's see. So 500 points, 500 points. And why is it not working? Very interesting. Okay, here we have our inputs. These guys get grouped. Oh, interesting. All right, for some reason this is not evaluating properly. So if I'm diagnosing the problem, so what I'm doing up here is I'm looking at the number of points, and it's at 750. Over here on this group SOP, it's being read as 500. So for some reason this node is having some sort of issue cooking. Easy enough to resolve, or it should be. I'm just displaying it, changing the frame. Now it says 750, so hopefully that's okay. Now this one still says 500, so it looks like it's kind of cached the result, and it's not liking it for some reason. So I'm going to force a reevaluation here. Really shouldn't have to do this, but perhaps there's a bug. Anyways, I've reloaded this, and we are now at 750. So the point count is consistent with both these guys. And I come back here to the group copy, and now to the blast, and now it's working properly. So that is odd that this didn't reevaluate when I change frames. But regardless, it's fixed. And we have this kind of procedural. We now have this kind of procedural setup, and the area is preserved regardless of the point count. Okay, so this is great. I'm going to drop down a null and say I will call this Prune. Oops, whoops. Prune out. Great. Okay, so say we want to cache this to disk now, right? We're happy with it. It's doing what it needs to do. Our supervisor likes it, and we want to cache it to disk. So in order to do this, we drop down another geometry output, and I will call this one Prune. And I'm going to connect it to my simulation. Whoops. And we set it to single frame, which basically means it's going to, for every frame in our sim, it's going to generate a single frame. We are going to pick a SOP path. So I'm going to go to the post sim prune and prune out, hit accept, and yep. I don't need to initialize simulation ops because it's not a simulation. And if you have a render farm, you could render it on that render farm, and each work item would be rendered separately. Because I'm rendering locally, I want all my prunes to be run in a single process. So I don't want to spawn up a bunch of different 240 different instances of Houdini to run this guy. And I'll just right click and go dirty and cook this node. And we let it run, and I will see you when it's done. And it's running super quickly, so didn't even have to wait. Beautiful. Okay, so I'm going to channel ref the output file so that I can read this in file parameter. And I'll drop down a file. put it here, go paste, relative reference, and there we go. There's our cache, our sim on disk, and it's cached. Yeah, so that's this example kind of wrapped up. In the next video, I'm going to kind of show a more complicated version of this. And what's going to happen in that one is I'm going to set up this group with this box, and what I'm going to do is say any agent over the course of the simulation that ends up walking through this box, I want you to delete it. And, delete that agent so it doesn't exist. Any agent that happens to come into this box over the course of the entire simulation, group that agent, and then we're going to delete it so it just doesn't exist in the sim. And that way we can ensure that over the course of the entire sim, there's no agent coming through this box. Yeah, so I will see you in the next video when we discuss that. Okay, we're back. Yeah, so this is a different file, or the file we used from the last example. I'm going to cache out the sim. I'll blow this guy away. Well, I'll keep it. Right click, delete this node's results from disk. Great. And I'm going to resim just a sim. Dirty and cook this node. And I'll see you when this is done. Okay, so our crowd sims cache disk. Let's take a look at this, at what we got. So this is our crowd sim. So what we want to do is I basically, over the course of the sim, there's a number of agents who enter this box. And what if I want to delete or prevent from existing any agent that ever enters this box over the course of the animation? Okay, so this is something we can do. What I'm going to do is, I'm going to do a number of things. I'm going to blow away all this stuff to start off with. Delete. I'm going to cut off this null just for the time being. I'll move these guys down. All right, so we need the agents that are in the box to be grouped, which is what's happening. Okay, the next thing I want to do is I want to create an attribute. So I'm going to go, I'll just use a wrangle. And if I want this to work on only the prune group, So prune. And I'm going to make an attribute called tag. I'm going to set it equal to 1. So if the agents are inside of this group, in this box, they're basically going to get a attribute with the value called tag, and it's going to be set to 1. If they are outside of that box, nothing's going to happen to them, right? So they're not going to be assigned a value to 1. They'll have the default value. And the default value for an integer is 0. So if we come take a look at the geometry spreadsheet, I'm going to hide all these attributes. And we'll just show the tag attribute that we created. There we go. And you can see it's a bunch of points are defaulting at 0. This one is set to 1. That's because it's inside of the bounding area or inside of the group. So we're good. And I'll rename this as tag atter. Okay, then the next thing I want to do is there's this operator called the SOP solver. Or the solver. And I'm going to hook this up. So the solver is basically a way of, it's kind of got like a, well, here, I'll show you really explicitly what it is. So if you dive inside it, it has a SOP network, right? So I can drop down wrangle. But it evaluates the current geometry, and it has information about the previous frame. And you can use this to basically run like a little simulation on your incoming geometry. So I'm going to connect previous frame over here, and I'm going to set the input on this side. So this is the current time step to this left-hand input over here in the wrangle. So then I'm going to use a point function. And I'm going to have it look at the second input, which corresponds to input 1, because these inputs are labeled 0, 1, 2, 3. So I'm going to have it look at that, and I'm going to see if there's a tag attribute. And that syntax correctly. Oh, I have to specify the point number. So I at pt none, so which is current point. And there's an error. I want to assign this a value, so I'll go int prev tag. There we go. Okay, so so what this is doing is it's basically saying, hey, is there a tag attribute over here on the previous frame? And if there is, well, there will be. Take that value and put that value into here. And what I'm going to say is if prev tag is equal to 1, then set 1, 2, 3, 4, indent it, then set okay, I'll write it out first and then I'll describe what's going on. So we're querying for the current point, we're querying it on the previous frame, the geometry from the previous frame. We're saying, give me this tag attribute. And then we say, okay, if this previous tag, or the tag value on the previous frame is equal to 1, then set the tag value on the current geometry that's being evaluated at the current time step, set that to 1. And let's see what we get. So I'm going to come back up here and reset the simulation. One thing I'm going to do actually, just so you can kind of appreciate this, is I'm going to right click and go allow editing of contents, just so you have a bit of an understanding of what the solver is. It's actually a DOP network, and inside that DOP network, there's this SOP solver, which is where the nodes we just created were placed. So this is basically it's DOPS kind of wrapped around a SOP digital asset wrapped around a DOP network, and you have the ability to edit inside one of those networks, and that's what this operator is. So you're still using DOPS; it's just kind of hidden and kind of concealed from you. All right, so let's see if we can visualize. I'll drop down a visualize what our tag attribute is doing. And attribute is tag. Visualize it as color. Interesting. Let me hide other objects. Maybe that'll help. Okay, not seeing it that way. Oh, maybe I should pick the class, point specific. Nope, okay. Let's take a look and see what we're doing. So tag, go forward, hide other attributes. So perhaps I've done something incorrectly. I have a better way to visualize this. I'll drop down a delete node, and I'll make a little expression. So at tag points, and I will say delete non-selected. Okay, so it looks like it's working. So what's basically happening here is as these agents, and I'll template the box so we can see this better. As these agents, I probably have an even better way of doing this. Yeah, I'm going to make a group. And I'll turn this off. And no, that's not what I want. I want group expression. So here we go. Display this, and the expression will be if at tag equals 1. I'm going to group points. There we go. This is a better way to visualize it. Okay, so let's start at the beginning and see what happens. So as any agents that are in the box on the first frame are going to be included, and then as agents enter, they'll join the group, and as they exit, they'll still remain in that group. So these tag attributes are basically the value. Once it goes in the box, the agent is given a tag attribute value of 1, and it keeps it. It keeps it over the course of the frame range. And I'm using that tag value to create a group. So if the tag value equals 1, put it in the group. And there we go. Okay, so then how do we get rid of these guys? Okay, very similar to what we did before, right? We drop down to time shift. And in this case, we want it when all these agents have, all the agents that could possibly have gone through the box over the frame range have gone through the box. And that's the last frame. So I'm just going to go delete channel, set it to 240. And then I can do a group copy. So now if we take a look at this time shift, we can scroll back and forth in the timeline, nothing changes. Group copy. I will rename this group to Prune. And over here, we could display this. I'll just bypass this, make sure it's evaluating. Come over here and turn on Prune. And we should have that copied over. And now I can drop down a blast. And say, to type in Prune. And that doesn't seem to be working. Oh, because I should probably rename this to something else. Prune, we'll call it Prune Anim. So it's conflicting with an already existing group. So let's call this Prune Anim. And I will blow away. I'll set this points Prune Anim. There we go. So now if we look at what we have, none of those agents ever enter the box. And we've kind of done this procedural prune. And this will update as you change the input to your sim. You can rely on this to kind of give you a predictable result that is reproducible regardless of what you do to your input sim. So let's go back to the top net and cache it out to disk. Right click. Delete this node's results from disk, which I think I already did, and dirty and cook this node. And this should be very quick. And there it goes. Great, and we're done. So if we come back here and take a look at our results and our file swap, we can scroll back and forth, and it does as we expected. Okay, so this ends the sections on procedural pruning. Okay, in this video, we're going to be talking about combining two sims, two separate sims, and having one influence the other. We're not going to be creating this one from scratch. I'm going to provide you with the file, and you guys can kind of refer to it. So the idea here is, we have an agent, we have a line, we have a crowd source. We're copying a bunch of agents on that. Then we're feeding it into a crowd sim. One of the things I'll note here, and that will become obvious, is that as opposed to like our kind of previous examples where we up at the object level, we'd have a rig, we'd have the crowd setup, we'd have the crowd source, then we have a separate object with the DOP node. Well, that's certainly the way the crowd tools are set up with these shelves. It's by no means the way you have to work. You can create your own shelf tool that basically runs Python script and puts everything into a single node. And in fact, doesn't even have to accomplish these things in separate steps. If you want, you could, potentially make one button that goes through and, sets everything up, provided, you have a kind of fixed idea of what it is you want to get out of a crowd sim. So if this looks a little different, that's totally fine. In essence, it's the same thing. So the agent crowd source, this is being fed into a crowd sim, and you can see it's just some agents walking. And then what we're doing over here is we're, taking some other agents, we're sourcing them, in a different pattern, and, we're coloring them red. And these guys we're coloring green. And I'll get into some of the details in a moment as to what's going on. But for the moment, I just want you to kind of appreciate the broad strokes. So, we have two things here. We have some, animated agents, right? And then we have these agents that have kind of been sourced into a position, right? Okay. So what we want to do is we want to use this sim over here on the right, these green guys, and we want to feed them into a second sim. And in that second sim, we want to simulate the red guys. But these green guys, we don't want to change anything about them. We just want them to, do what they're doing. But what we want to have is we want to have these red guys react to the green ones. So that is essentially what's being done in this sim. So you can follow these guys. And the red guys are reacting to the green ones, but the green ones are, just doing what they did previously. So, this has a number of different applications that, I can think of, right? So you can do something like this, which is fairly straightforward. The other thing you could do is you could have a sim, and you could, sim a bunch of agents and say there's 100 agents, and you show it to your supervisor and they're like, hey, this is great. I love all of it except for these two agents. Can you make them move differently? Well, you can, right? So you just take the sim, prune out the two agents that you don't like, feed the 98 agents that you do like into the new sim as this kind of static animated objects, or what we call targets, and the other two you just source in as regular kind of agents and resim them whatever way you like. This workflow will accommodate that. Anyways, let's talk about the mechanics of this one a little bit. So the first thing here is we got this attribute delete, and it's deleting this orient. And the reason why this orient is being deleted is it's not. And there's a little note to this effect here. It basically says this isn't strictly necessary. It just avoids having the newly merged agents. So these guys over here, the red guys. Default for their orient attribute. And instead, this lets the crowd solver compute it from the prim transform in the second sim. So basically, it's a way of not squashing the orientation of these red guys. So that's why that's there. There's an attribute that is created here called crowd animated, and it's set with a value of 1. And this is basically just flagging for the second Dobson that these agents just, leave them as they are, right? Don't do anything to them. And because this attribute is set with a value of 1, when it gets merged with these guys don't have that attribute. These will default to a value of 0. If you wanted to, you could set them explicitly, which is actually probably just good practice. And so I've set these guys to 0, and we can kind of scroll forward. We can sim forward, or resim rather, and we should get, good results. So that's what this set crowd animated is about. And if we look in the sim in terms of setting this up, it's really straightforward. And again, this is like a very, very simple sim, right? Just used to illustrate what's going on. It's we have the crowd. It's being sourced, or the crowd object, excuse me. And the target it's using the first context geometry. Okay, so what that means is it's basically looking at the first input to find um, these target agents, right? And so it looks at that first first input, and it says, okay, any of these guys have a crowd animated attribute set to 1. If they do, just bring them in and don't do anything and let the other agents react to them. And that's what it is. Very, very handy, very, very useful, very good for being able to address notes and not have to resim an entire sim just to fix a couple of characters. Okay, I'll save this file, and that's it for this video. I'll see you in the next one. All right, this example is I kind of referred to it in the previous one, so I thought I'd just spend a couple of minutes and put the file together so you can actually see the workflow. So what this is it's a simulation that I've cached to disk, fairly straightforward, and we're doing after the fact, we're taking this cache sim and modifying only a couple of agents in it. So let's say you are working on a shot, and you show this animation to your supervisor, and they're like, yeah, it looks great. Everything looks great except for these two agents right here. Instead of having them start by running down the z-axis, let's make them run this way down the x-axis. So one of the options is for doing that is you could change these two guys specifically, or try and resim and change these two guys specifically, but you run the risk of the other agents behavior changing. And if your supervisor likes everything as is and it's like, don't change anything, just change these two guys, and they're really specific about that, this is a kind of workflow that can accommodate that. So and that's what this resim node is here. So what I do is I basically object merge in the sim that I've cached to disk, and I'm using a bounding object to group the two agents I want to kind of separate, and then I'm blasting those two agents away. So I'll hide. So blast those two agents away. And at the same time, I'm coming over here and doing a group copy to, from the crowd source. Don't really need to do this. Let me see. Yeah, actually, this is probably done better with a split, now that I think about it. So group copy, split, and what's the name of the group? To resim. Okay, groovy. And I can input, these are the, one guy, and these guys are over here. These are the two agents that I've kind of isolated. Groovy. All right. And just for good measure, I will time shift this. I don't think it's necessary, but I'm going to. This is actually a little bit better version of this rig. Okay, so let me go back to what I'm doing here. So I've made this group, bounded these two agents, copied the group over to the original sim, and then I'm using a split. This is splitting off all the guys that don't want to sim or resim, and the guys that I do want to resim. And with these guys, I'm time shifting it. I'm deleting all the geometry, but just keeping the points, deleting all of the attributes, just so it's clean geometry. It's basically 2 points. And then I'm taking the agents, the agent that I used in the original setup. So yeah, and I'm just coming back here and um, crowdsourcing them onto these 2 points, right? Great. And over here, there's this randomize tab, and you can use it to randomize things, but in my case, I'm just going to explicitly set the velocity to be looking down the x-axis rather than the z-axis, which is what they were doing before. So we can come in. So this is kind of where they were heading before, and then this is where they're heading now. And again, this is the simplest example of this. Then I take the original crowd, I delete that orient attribute, and I add the crowd animated attribute, and I set it to 1, which basically recognizes that these guys will remain as they are. And over here, I add the same attribute, but I set it to 0, letting the sim know that these are the guys to be simulated. And then I put them into my .NET. Give this a sec. So just a couple other little pieces of information here. This .NET and the contents of it, basically the way I got it is I just took the original CrowdSim and I copied these nodes. And I created a .NET node down here and I pasted them inside. So that's literally the same thing. The only difference here is I made an adjustment to the target geometry. So it's using the first context geometry, so the first input. And on the crowd source, it's also sourcing from use first context geometry. So, and there we go. So then there's a null node here, and this is what I'm going to point at when I use my geometry raw. So let's go over to the top network, and we can write this out to disk. So here I have the original sim, and this is the kind of fix or the resimming 2 agents that happens afterwards. And this basically is a wait for all. So say I needed to resim everything. I'd want to wait for the first sim to simulate before I'd start the second one. Anyways, let's run this sim and let's see what we get. So, and I will see you when this is done. Okay, so we're done. Um, yeah, if we let's take a look at what we got out of this Resim. So there you are. Your agents are kind of pointing in a different direction. Oh, I don't think I have the cache node displayed. I do not. Come here. File swap. Rather, so yeah. So here you kind of have the initial direction of these guys is now pointing out this way. Um, but that's that's not to say like this is a very simple example, but you can change anything you want in this DOPSIM, and these agents will remain the same. And whatever you compute in the DOPSIM will change. So we can do things like change the playback time, or what where this trigger takes effect, and it'll just do it for these two agents. And we can do a comparison, right, between what we simmed before, right? So this is what came out of the original sim, and this is what came out of our sim. And we can kind of toggle these guys on and off and see how they compare. And you can see that those two agents have now been replaced by these two guys. So you can, this DOP network can become, completely different, and still, and only affect these two agents without affecting the rest of these crowd agents that you've simmed. And that's the real power behind this kind of workflow.